You know that feeling when you open an app, maybe your social feed or an online store, and everything just snaps into place
Yeah.
instantly?
Oh, yeah, totally.
Posts appearing in milliseconds, products loading right away, even with like millions of people online.
It's what we expect now, isn't it? Seamless.
It really is, and it's incredibly satisfying. But if you've ever worked on software, you know that speed isn't just magic, right? It's some really clever engineering.
Definitely not magic. Lots of hard work behind the scenes.
So today we're doing a deep dive into one of those really core engineering solutions, caching. Specifically, caching in backend APIs.
Mm-hmm. Crucial stuff.
Now, if you're familiar with backend APIs,
Mm.
those sort of invisible engines handling requests and data behind everything you see on screen,
Mm-hmm.
well, our mission today is to unpack what caching actually is.
Yeah, how it works.
Exactly how it works, and maybe most importantly, why it's just absolutely critical in today's, super fast, data-heavy tech world.
It really is paramount. I mean, just think about the sheer scale. The amount of data, the number of users hitting apps every single second.
It's mind-boggling.
It is. And without smart techniques like caching, honestly, the internet as we know it, that instant experience, it would just, well, grind to a halt.
Okay, so let's unpack that. From an engineering angle, what exactly is caching in this context? Where does it fit in?
Right. So, at its core, caching in backend APIs is all about making data access incredibly fast, like ridiculously
What's
fast,
the normal?
much faster. It's basically a technique where you temporarily store data that gets accessed a lot. You put it in a really fast, easy to reach place.
Okay.
So the application doesn't have to keep going back to the original source, which is often slower, like a database or maybe an external service. Every single time, it needs that same piece of information.
I've heard an analogy like keeping frequently used phone numbers on a notepad on your desk instead of looking through the big directory each time. Is that close?
Yeah. That's a great analogy, actually. Yeah, it's exactly like that. You keep the important stuff close by and quick to grab.
Or maybe like a chef prepping ingredients. They don't run to the pantry for every single pinch of salt.
Right.
They have it ready.
Exactly. That's another perfect one. The chef preps, sets up their mise en place. Caching is like the digital version of that, bringing the data ingredients right up front, ready to go.
Makes sense. So can you give a concrete example?
Yeah.
Like in that shopping app scenario?
Sure. So imagine a back-end API for a shopping app. Think about popular products, maybe the top 10 bestsellers.
Okay.
Instead of hitting the main database every single time anyone looks at those popular product pages to get the name, the price, the image URL.
Which could be thousands of times a minute.
Exactly. Thousands, maybe millions.
Yeah.
The API can store those details in a cache. So when you or anyone else requests that popular product, boom, the API serves it from the cache almost instantly.
Okay. So it avoids that slow database trip.
Precisely. Makes the app feel way faster, more efficient, handles load better. It's a win-win.
Got it. So to really get this, what are the key terms, the jargon we need to know?
Good question. There are a few core concepts.
Yeah.
First, you have the cache itself. That's just the temporary storage area.
Like the notepad or the chef's prep station.
Exactly. It could be just memory within the application, or often it's a dedicated system like Redis or memcached, which are super fast.
Okay, cache. What else?
Then you have a cache hit. That's
Yeah.
the good outcome. It means the data the API needed was found in the cache.
So super fast response.
Bingo. Lightning fast. The opposite is a cache miss. That's when the requested data isn't in the cache.
So then you have to go back to the directory or the pantry.
Right. The API has to go fetch it from the original source, the database, maybe. And here's the key part. After fetching it, it usually stores a copy in the cache for next time.
Okay, so a miss is slower, but it helps populate the cache for the future.
You got it. Then there's expiration. Cache data can't live forever, right? It might become stale.
Like an old price or something.
Yeah. Exactly. So cached items have a lifespan, maybe 5 minutes, maybe an hour. It's called a TTL, time to live. After that time, it's considered expired and gets removed or needs refreshing.
Makes sense. Keep it fresh.
And related to that is invalidation. This is super important. It's when you actively remove or update something in the cache before it expires.
Why would you do that?
Because the original data changed. Like if that product's price gets updated in the database, you need to invalidate the old price in the cache immediately. You can't wait for it to expire naturally.
Right. Otherwise, you
Yeah.
sell it at the wrong price. Ouch.
Yeah, exactly. So invalidation is key for data consistency. Cache, hit, miss, expiration, and validation. Those are the big ones.
Okay, that framework helps a lot. So how does this actually work in the code, like step by step? What's the flow?
The flow is actually pretty logical when you break it down. First, developers have to identify cacheable data.
Stuff that doesn't change too often but gets asked for a lot?
Precisely, like top-selling products, user profiles that don't change much, configuration settings maybe, things that are read way more than they're written.
Okay. Step 1. Identify.
Step 2, when the API gets that data for the first time, maybe from a database like MySQL, it stores a copy in the cache. Could be in memory, could be Redis, whatever cache system they're using.
So fetch once, store once?
Initially, yes. Then step 3, handle user requests. Now, when a request comes in for that same data,
Check the cache first.
you got it. Always check the cache first. If it's there a cache hit, send it back immediately. Super fast, no database needed.
Nice. And if it's not there?
That's the cache miss scenario. Step 4. If it's a miss, the API goes back to the original source, like the database, fetches the data.
Okay.
It sends it to the user who asked for it,
Yeah.
and puts a copy into the cache for next time.
Got it. Fetch, send, and store for later.
Exactly. Step 5 is manage the cache lifespan. Remember expiration. The data stored in the cache gets that TTL, that time limit. Maybe product prices are cached for only 10 minutes.
All right, to keep it reasonably fresh.
And step 6, the crucial one, update or invalidate the cache when the underlying data changes. Product out of stock, price change. Invalidate that cache entry now.
Don't wait for the TTL.
Nope. Got to keep it accurate. And maybe a final point, step 7. Modern tools and frameworks integrate all this really nicely.
Like Spring Boot, you mentioned.
Yeah, Spring Boot in the Java world, for example, has libraries like Spring Cache. Or you integrate directly with Redis libraries. It makes implementing this workflow much easier for developers.
So you don't have to build it all from scratch every time.
Thankfully, no. For instance, a Spring Boot API for, say, a news website could easily cache the top 10 trending articles in Redis. User hits the homepage, check Redis first, boom, article served instantly, no database hit unless it's a miss or expired.
That paints a really clear picture of the mechanics. Okay, so we know the what and the how, but why? I mean, it sounds like extra complexity managing this cache layer. What specific problems does it solve? What was life like before good caching?
The why, that's where it gets really compelling. Because life before widespread easy caching, well, it was slower. A lot slower.
So.
The biggest pain point was just slow response times. Imagine a retail app during a holiday sale. Without caching, every product view, every category browse might hit the database hard. Pages taking seconds, not milliseconds, to load.
Which users hate.
Exactly. Users abandon slow sites. Caching solves this by storing that frequently accessed data product details, category listings in a super fast place, usually memory, so response times drop dramatically. Seconds become milliseconds.
Okay, speed, that's huge. What else?
Reduce server load. This is massive. High traffic applications, especially during peak times like a big product launch or a viral moment,
Yeah.
they could just absolutely hammer the database. Constant queries. This overloaded the database servers, leading to slowdowns for everyone or even outright crashes.
Not good.
Definitely not good. Caching drastically minimizes those database queries. Fewer queries mean less load on the database, freeing up its CPU and memory. This is crucial for stability in high-traffic scenarios, like e-commerce during Black Friday.
So it makes the whole system more robust.
Absolutely. Which ties into the next point. Improved scalability. Before caching, if your user base grew, your API servers, and especially your database, often couldn't keep up without very expensive upgrades. More servers, bigger databases.
Probably scaling.
Very. Caching allows an API to handle many more users without proportionally increasing the load on the backend database or primary servers. You serve a lot of requests right from the fast cache. Think of a streaming service caching movie titles and descriptions. Lets them handle millions browsing simultaneously.
Right, because most people are browsing the same popular movies anyway.
Precisely. So better speed, less load, better scalability. What does that lead to?
A better experience for the user.
Exactly. It enhances the user experience. Nobody likes laggy apps. Slow shopping carts get abandoned. Slow feeds are frustrating. Fast, responsive APIs powered by caching create smooth, enjoyable experiences that keep users engaged.
That makes total sense. Any other big wins?
Yes, cost savings. This is especially true in the cloud era. Cloud providers like AWS charge you for database reads, network traffic, compute resources.
Every little bit adds up.
It really does. By reducing database queries and the load on servers, caching can significantly cut down on those operational expenses. Lower hosting bills, that's a big deal, especially for startups watching their budget.
Wow, okay. Speed, stability, scalability, user experience, cost. That's quite a list.
And one more, maybe more for the developers listening, it often simplifies optimization. Before easy caching tools, getting performance boosts might have meant really complex database query tuning or rewriting core logic.
Deeper, harder changes.
Yeah. Now, tools like Spring Cache or integrating Redis are relatively straightforward. It allows developers, even those who aren't deep performance experts, to add significant performance improvements fairly easily.
That's powerful. So bringing this all together, what does this mean for right now in 2025? Why is caching more critical than ever?
It really feels like it's gone from a good practice to absolutely essential for several converging reasons. First, just the baseline user demand for speed is relentless.
We're impatient.
We really are. Studies show even tiny delays, like a few hundred milliseconds, can cause users to drop off, especially in e-commerce. Instant loading isn't a luxury, it's the expectation. Caching is fundamental to meeting that.
Okay, user expectations are sky high. What else?
The sheer explosion of data and traffic. Think about platforms like X, TikTok, massive online stores, streaming giants. The volume of data they manage and the number of concurrent users are astronomical compared to even a decade ago.
Unimaginable scale.
Right. Caching is basically the frontline defense that stops the underlying databases from melting down under that constant, immense load, especially during peak times.
It acts like a shock absorber for the database.
That's a good way to put it. Then you have the cloud and microservices trends. So many applications now run in the cloud, often using a microservices architecture where the backend is split into smaller, independent services.
Like a payment service, a user service, etc.
Exactly. Caching becomes vital not just for the whole system, but often within or in front of each microservice to ensure they respond quickly. Slow microservices create bottlenecks in the entire request chain. So caching helps keep these distributed systems scalable and performant.
Ah, okay. So it's important at multiple levels in modern architectures.
Definitely. And don't forget mobile usage growth. Most internet access is mobile now. Performance on smartphones is critical, but phones have limitations, CPU, memory, and especially variable network quality.
Yeah, connection speeds can be all over the place.
Right. Caching helps APIs minimize the amount of data they need to fetch and send over potentially slow networks, making apps feel responsive even on a weaker connection.
That's a really good point. Makes mobile apps usable.
And we touched on cost efficiency in the cloud already, but it's worth emphasizing. As cloud usage grows, optimizing resource consumption is huge. Caching directly reduces database load, network egress, and compute needs, translating to real dollar savings.
Makes business sense.
It really does. Also, reliability and cybersecurity. A slow, overloaded API isn't just frustrating, it can be a sign of inefficiency and potential vulnerability. Systems under strain are sometimes easier targets for things like DDoS attacks. Caching reduces that strain, improving overall system resilience and stability.
So it even has security implications.
Yeah.
Interesting.
Indirectly, yes, by improving robustness. And finally, think about developer productivity and the job market. Tools for caching are mature now, making developers more productive. And because fast, scalable APIs are so critical for businesses.
Companies need developers who know how to build them.
Exactly. Skills in implementing caching strategies, using tools like Redis or Memcached, understanding cache and validation patterns. These are really valuable in-demand skills for back-end engineers, web developers, even DevOps roles. Learning this stuff opens doors.
It really sounds like it touches almost every aspect of modern application development and operation. The impact is just everywhere.
It truly is. You see it in action constantly.
Like Amazon during Prime Day. They must be caching product data like crazy in their APIs to handle that traffic and keep pages loading fast. That speed directly impacts sales, right?
Absolutely. Milliseconds matter in e-commerce. Or Netflix, think about browsing their catalog. All that movie metadata, posters, descriptions, heavily cached for that smooth, instant browsing experience across millions of users.
And social media.x, Instagram.
Billions of requests a day. Caching user feeds, timelines, profile info is the only way they can possibly display that content instantly when you open the app.
It's fundamental to their operation.
Totally. And it's not just the giants. Even a small startup, maybe building a fitness tracking app, they'd likely cache workout definitions or user stats to keep their API snappy and responsive. That improves user retention. People stick with apps that feel fast.
So, yeah, it's clear caching isn't just some obscure technical detail. It's a core enabler for the apps we use constantly and for the businesses behind them.
Couldn't have said it better myself.
Okay, so for someone listening, maybe a newer developer or someone just curious who's thinking, wow, this sounds powerful, but maybe complicated. How accessible is it to actually learn and implement this stuff?
That's maybe the best part. It's actually very approachable these days, especially to get started. You don't need to be a systems architect ninja from day one.
Where would you suggest they start?
First, just learn the basics. Find some good tutorials online, places like FreeCodeCamp, maybe some YouTube channels focusing just on the concepts. Cache hit, miss, TTL, invalidation. Understand the what's and why.
Get the core ideas down.
Exactly. Then, if you're working with a specific stack like Java, explore Spring Boot's caching support. The official Spring docs, spring.io, or sites like Beldung have excellent tutorials on integrating Spring Cache or using Redis with Spring.
So, focus on the tools for your environment.
Right. And the most important thing, build simple projects. Don't just redo. Create a basic Spring Boot API, maybe for a simple product catalog or a blog. Then try added caching. Measure the response time before and after. Seeing that difference makes it click.
Hands-on experience.
Absolutely essential.
Hmm.
And use the tools. Spring Initializer, start.spring.io, makes setting up a basic project incredibly easy. You can often get started with Redis using free tiers on cloud platforms or running it locally with Docker. Low barrier to entry for experimenting.
Good point. And if they get stuck?
Join communities. Stack Overflow is obviously a huge resource. Reddit has great programming forums like Java or Learn Programming. Ask questions, see how others solved similar problems. The community is usually very helpful.
That's great advice. Learn, explore, build, use tools, ask questions. Seems like a solid path. Well, this has been a fantastic deep dive. We've really unpacked what caching is, looked under the hood at how it works, explored the critical problems it solved, speed, load, cost, user experience, and really emphasized why it's more vital than ever in 2025. It truly feels like a cornerstone of the performant applications we rely on daily.
Absolutely. At the end of the day, caching makes apps faster, more scalable, and more cost-effective. It's essential for delivering those seamless user experiences we all expect now, and it empowers developers to build really robust, efficient systems. And maybe a final thought for you listening. If you're someone who appreciates the speed of your favorite apps, or perhaps you're even thinking about building something yourself one day, this deep dive hopefully shows that a lot of that magic speed comes down to clever but understandable engineering like caching. So maybe the question to ponder is, now that you know caching is actually quite approachable, how might understanding this change the way you think about the apps you use every single day? Or could it even inspire you to start exploring how to build these kinds of high-performance systems yourself?